Okay, so what I'm going to show you now is how to take a Keras model and put it into an Android application really easily. So I'm going to do it with a really simple model, and that's the XOR model. So what is XOR? Well, basically you can see here our input is this column right here, and if either of the two inputs is 1, the output will be a 1. Otherwise, if they're both the same, if they're both 0, or if they're both 1, the output should be 0. It's an XOR gate. It's really simple. And we're going to try to make a model for that. So first thing we're going to do is we're going to open up Python. So let me just open that up right now. Okay, so first thing that we want to do is we want to import our packages. Import numpy as np. So for this project, we're going to need numpy, Keras, and TensorFlow working in Python. So in Python 3 is what I'm using. So import numpy as from Keras.models import sequential. So it's going to take a second to get that TensorFlow. Got TensorFlow. Keras.layers.core import dense. The only layer we're going to be using in this neural network is the dense layer from Keras. So that's what we're going to be using. Now we're going to need to define our inputs. They're going to be the same set of inputs from this table right here. X equals, and Keras obviously needs to be passed numpy arrays. So we're going to do numpy.array 0 0 1 0 0 1 and 1 1. And the type is going to be float. Whoops, there too. Is that good? Looks good. All right, now we need to define our outputs, and they need to correlate to the indexes of the inputs. So we're going to go numpy.array. So 0 0 is going to generate a 0. 1 0 is going to generate a 1. 0 1 is going to generate a 1, and 1 1 is going to generate a 0. So move that. And then again, they have to be of type float 32. Boom. So that's easy. So we got our x and a y. Now we need to define our model. So we're going to say model equals sequential. Cool. All right. Model equals sequential. Model.add. We're going to add a new layer. It's going to be a dense layer. So we're going to be the input dimension is going to be, let me just make sure this is right. Yes. Input dimension is going to be 2, obviously, because that is, we're passing in 2 inputs, so our input dimension is going to be 2. Activation equals sigmoid. And it's going to have, yeah, we'll go with 16 hidden units there. So we're going to be that, and then that. Oh, whoops. The 16 needs to go first because it's a positional argument. I forgot about that. 16, yeah, see, I was wondering. And then we get rid of this. All right, so it gave us a warning. We don't care about warnings right now. It's all good programmers should. And we go model.add our final output layer, which is going to be, again, a dense layer. It's going to be output size of 1 because obviously our output is only 1 dimension. So output 1, and our activation equals sigmoid. So our model's that. Now we need to compile our model. So model.compile. Let's see. Loss equals mean squared error. Our optimizer is going to be Atom. And our metrics is going to be binary accuracy. Just make sure I spelled accuracy right. Okay. So we're going to try compiling this. Hopefully this works. And our model successfully compiled. So that's great. All right. Now we're going to train our model. So we're going to do model.fit to x, y. We're going to go with, I think we're going to go with 3,000 epochs just to be safe. And verbose equals 1, so we can see sort of what it's outputting. So here we go. Actually, I'm going to go with verbose 2 so we can see the accuracy there. All right, so it's training right now. You can see the binary accuracy is, well, it looks like it's at 100% right now, so that's great. So, and we're only, looks like about 1,000 epochs in, so now 1,500. So we didn't need to do 3,000, but, that's okay. So yeah, it's just training. Make sure to have those dependencies. Obviously, you're going to need Keras, Tensor, and NumPy. Without those packages, this isn't going to work. But we got it. So we have our model. Now what we need to do is we need to save our model. Okay. So Keras has a really handy method called save. So we're going to model.save. We need to give it a location. C users Andrew documents. Oh, model.h5. And we're going to save it. So our model has successfully been saved as model.h5. So if we go to documents, we should be able to see it. What the heck? Actually, we're going to do this from command prompt because we're coders. Okay, so we're going to cd documents. So we're here. We're in documents right now. Now, here is the really important bit. What you need to do, and when you install TensorFlow, this is going to be already installed, but it's this TF Lite converter. And I want to make sure I get the syntax on this right the first time. Okay, so you're going to type into your command line TF Lite convert. In fact, I believe this also works on your Mac terminal or your Linux terminal as well if you have TensorFlow installed, but you want to do TF Lite convert output. Our output file is going to be model.tflite. So why are we doing this? Well, Android tends to really like to use TF Lite, TensorFlow Lite models for their machine learning stuff. So we're going to convert our Keras model to a TF Lite model. So we're going to do the output files model TF Lite. Our we need it to be, yes, Keras model file equals model.h5. Okay, so output file that. No, I just didn't hit enter. How about that? So we're going to go to great. All right, so model.tflite, we created it, so that's awesome. And this is our model.h5. This is the one that Keras made. So we have this TF Lite file. Now what do we do with it? Well, we got to first open up Android Studio. So I'm going to close this file browser for now, and we're going to type in Android Studio. We're going to pop that open. And I'm trying to do the simplest tutorial possible, so we're not going to do any, fancy GUI stuff. All we're going to do is we're going to try to have the console output the correct prediction for this function, okay? All right, so new project, empty activity, next. My application, sure. All right. So we have this brand new application. Let me plug in my cell phone here. All right. So you've got your vanilla main activity right here. So this is going to be the first method that runs when the main activity starts, this onCreate method. So we're going to be doing everything in there. And like I said, everything's going to be done in the console. But first, we need to do a couple things in this file called Gradle. So we're going to go to the Gradle scripts, and we're going to go to module app. There's two Gradle, build.gradle files. We're going to want to go to module app, okay? So what we need to do is we need to first give it the libraries that it needs, or tell it to implement the libraries that we need. This stuff I don't know off the top of my head, so I'm going to look at the notes on my other screen here. Okay, so we're going to tell it implementation org dot TensorFlow Lite 0.00 nightly. So this is the library. This is to tell it to use this library to be able to interpret the commands we give it. So we're going to sync the Gradle to make sure I didn't type that right. Yeah, so it's going to try again. And hey, it built. So one thing that I like to do before I do anything also is I like to deploy it to my phone. So we're going to deploy it just to make sure everything's running before I add extra code. See Gradle build running. All right, so we got it running. You can see right here, it's a really exciting app, as you can tell, just a really empty activity. So we have that. So now what we're going to do is there's two more things we need to do in this Gradle build file. So what we need to do is we need to go into the default config right here and type in ndk ABI filters equal ARM ABI v7a ARM 64 v8a. So you don't really need to worry about what these things do. You just need to have them in there. I can tell you what this next thing we need to do is we need to add this option here and tell it no compress TF Lite, no compress Lite. So what does this line do? Well, it tells it when it stores stuff in the memory not to compress the TF Lite files. You can kind of imagine the TF Lite file as sort of delicate, and you can't really compress it or else it breaks things. Interesting way to think about it. So now what we need to do is we need to actually bring that model, this magical model we made, and put it into our project. Okay, so we're going to need to put the TF Lite file into the project. So we're going to take it, we're going to copy it and put it on the clipboard. Now this is the interesting step that isn't really that intuitive. Make sure you're in Android, in the Explorer here. Going to right click the app. Okay, and what we're going to do is going to do new folder, assets folder. So this is a place where the Android app can look for our stuff. To do sure, so we'll do that. And so that's good. So the resources, it's going to be, this assets folder is going to be, now you need to go to project view. Okay, you're gonna go here, and we're gonna look at app, src, main, and our asset's gonna be right outside the Java folder, as I understand it. Yeah. So now you just right click it and paste our model.tf Lite folder right in the assets folder. Boom. So we have it in there. You can see it, model.tf Lite. I can make sure I did that correctly. Okay, so I did that correctly. All right, now here's the interesting part. We're going to go back to our, although it's telling me I did something incorrect here. What did I do that was incorrect? I'm going to try to build this again. I don't know. Oh. Try again. And it built. Okay. So now all we got to do is code it. Okay. Now there's a couple lines of code here, and it's going to look very similar to that that Python code we coded before, but it's going to be written in Java. Okay. So we're going to go to main activity, and there's really two lines that actually use the TensorFlow, the TF Lite model, and it uses object called an interpreter. So we're actually going to build that. Let me go to my notes here to make sure. So we're going to do interpreter equals new interpreter. Now in the interpreter we need to pass it the file. We need to pass it the this model.tf Lite file to the interpreter. Okay, and then what we'll do is we'll do interpreter dot run our input and then an output variable for us to save it. Then boom, we're good to go. However, we can't do that yet, and we also need to create our file object. So the way to do that is you're going to use an asset descriptor object. Asset file descriptor, I'm sorry. File descriptor. Get assets. Boom. Okay. What the heck? So what does this do? Well, I also just surrounded with a try catch because this object is going to go into our assets, find the model.tf Lite file, and load up some information about it. But I need to surround and try catch in case it doesn't exist. It'll throw an error. Okay. So we have that. Now what we're going to do is going to basically get some of the information from it. Let's load these things so we have them. Oh, whoops. Skipped a line. Boom. All right. So we need to open up our file import stream to read the file. So we got that. We got our file channel to actually get the information from the input stream, or at least some of the information. The information we want is the start offset and the declared length. So we're going to do long start offset dot get boom. And now what we need to do is actually get our buffer stream, our byte buffer of the file itself, which we can pass to the interpreter. All right. So that's going to be pretty easy. All we do is create a new byte buffer. Byte buffer TF Lite file equals file channel dot map. So again, these lines, to anyone who hasn't really worked a lot with Android and their file system, can look a kind of unwieldy and complex, but it's really only 1, 2, 3, 4, 5, 6 lines that load up the file, and all it really does is make sure it gets loaded up without compressing it or doing anything funny with it. So it's these 6 lines. You don't really need to know how they work because it works the same for pretty much every TF Lite file that I know of. You just basically, every time you need to use a TF Lite file, just use these 6 lines. And now we can create our interpreter, okay? Interpreter equals new interpreter. And now we can pass in our file. And it's happy now, so it has that. All right. Now we need to define our input and output arrays. Just like in Python when we did it up here, let's see, maybe it still has it. Yes, it does. How about that? So we need to define our arrays here. This is in Python. We're going to define them in Java. So it's a little bit different. So we're going to float, put array equals okay, so we got our input array, and now float output array. Actually, that wasn't even necessary, this output array, because we're just testing it, but, you know. So, and like these things look very similar to the ones we made in Python, because they're just, you know, the same arrays. So now what we need to do is predict. So we're going to do this one line that says interpret. Oh, actually, I forgot this. Okay. So these should actually be 0. So what the output array actually is, I forgot why I made that, is a placeholder for the actual the interpreter to put the information in. So it needs to be the same size as what the interpreter, what the model is going to output. So we're going to do interpreter dot run. So run is very similar to the predict method in Keras. And we're going to do our input array and output array. And it's as easy as that. So when you run this thing, it's going to take the output of the model and it's going to fill in these values. Okay? So, and ultimately what it should be is that it should be really close to 0 for the first element, close to 1 for the second, close to 1 for the third, and close to 0 for the fourth, because that's what the XOR model should output. So how do we figure that out? Well, we're just going to print it. So we're going to do for float out in put array print system dot out dot println out 0. All right. So now if we run this, and actually I'm gonna tag it so that I can search it really easily and find it. So what's the problem? Oh, forgot to get rid of that. And cool, so now we're gonna run it. I'm gonna go to logcat, type in AJ So now, if this worked, it should output. Hey, all right, so it worked. So we got really close to 0, really close to 1, really close to 1, really close to 0. So our model is successfully deployed on an Android device, and it gave a correct prediction. So I hope you found this helpful, and thanks for watching.